In this lecture, we talk about the discussion of choosing parameters for the ARIMA model. And we're going to use that airline passenger and daily total female birth data set and just import them, identify the frequency of the data. The first one, the airline passenger, we have the monthly start and the daily for the daily total female birth. So let's just create the data frame for those. And if you have not still installed the PD ARIMA, don't forget to do that. Just use any of these functions and install the library, import the PD ARIMA, and then from the PD ARIMA, we are going to import the auto ARIMA. Kind of gives us the parameters. If you want to learn more about it, of course, you can run the cell without the comment and kind of learn about that auto ARIMA. So let's apply the auto ARIMA for the daily female birth data set. It's a non-seasonal data. There is no seasonal component. And it says what was the maximum iterations, what was the order you had identified, the 111. So PD and Q are all 1. There is no seasonal order, which we expect. And we can also apply the auto ARIMA and get the summary of its model. So the even though it says ARIMA X, it's a ARIMA with order PD and Q 111, the BIC and the AIC calculation. Now what we can do, we can see how this was determined by looking at the stepwise results. Okay. So we look at the minimum value for AIC, and that will be the one we want. Let's just fit different values of PD and Q and see what are the AIC results. So if you look at these different types of ARIMA, right, so we start the basic one and then we get to the we get to the 111 and look at the AIC here. It's 2460, and also we have another AIC very close to that. But again, these are more complicated models. We may want to stick with the simpler model, but this is definitely the one we have that has the least AIC. And it fit the model, again, the result we saw earlier. If you look at the non-stationary data, airline passenger data with the seasonal component, and look at the results of the auto ARIMA, you can identify bigger values for P and Q, but we're going to stick with the P and Q 3 and 3. But don't forget, when you have identified a large value for P and Q, the algorithm auto ARIMA stops at the point that identifies the model is not going to be improved. So we don't see a high value for P here, right? So it kind of stops at the value of 2. Doesn't mean that the algorithm is not able to do that. It just sees that the auto ARIMA sees that there is no improvement in the model. So why we complicate it? So same here. Let's just run different ARIMA and get a look at the values of AIC. See which one has the least value for AIC. We see one here with 1022. See if we have less than 1020. We have 1011 or 110. And it looks like we don't have anything better than that. So that 011, even though the AIC is bigger than 1017, but it's simpler. Also, we need to have that seasonal component. So we can have, okay, 001 with the seasonal component 1112. Perfect. So this is the one that we can select. And if we look at the ARIMA select function. Of course, it gives us the help if you want to get to know it. What happens is it looks at different types of P and Q combinations and select the minimum value. So let's just run that, the ARIMA select, and so this is the first column, P, and then the row is the Q, right? So what are the values? What is the least value for P and Q? Let's find out. So we have 2484. Do we have less than that? It looks like this is the minimum value for P and Q for the BIC. So we select the first column, or the column 1, and the row 1. So these are the parameters for the ARIMA, or the P and Q parameters. And we can do the same thing for the thousands of passengers example. Use that ARIMA select, and let's take a look at the values. So what is the minimum value? So 1413 is the third row, so P is 3, and the column is actually 1400. P is 3 and Q is 2. I think I said the first one the wrong order. So the P is the row and Q is the column. So row and column. And that's how you can select directly or identify the P and Q based on the ARIMA select model. So hopefully you can also take a look at the examples and run that specific function for your case. So that's it, and good luck.